They're orbiting one another, and as they orbit, they disturb the space-time around them and create waves of energy. And the energy to do that slows the stars down so they get closer and closer together. As they get really close together, they're orbiting around hundreds or even 1,000 times per second. The final event is very dramatic.
When two neutron stars collide, they're moving at nearly the speed of light. Although the final collision takes only a fraction of a second, it unleashes more energy than the sun will generate in its entire lifetime. Thanks to computer modeling, we can also predict what would happen if a highly dense white dwarf collided with our sun. It would be a frightening collision.
When it got close enough, the gravitational field of the white dwarf would start to distort the sun, so the sun would no longer remain a sphere. It would sort of turn into an egg shape as this thing came close.
As the white dwarf plows into the sun at supersonic speed, its gravity would send an enormous shock wave throughout the star.
And that would produce so much thermonuclear energy to essentially explode the sun.
Amazingly, it would take only about an hour for the white dwarf to plow through the sun and annihilate it. If this scenario came to pass, life on Earth would be doomed. Fortunately, the chances of this happening are slim because the sun is in a very uncrowded part of the Milky Way galaxy.
Individual stars are kind of jostling and weaving as they make their great circuit around the galactic center. So it's a complicated traffic situation, but because the space between the stars is so great, there's not much chance of a collision. If you were to wait out here on this beach until you saw the collision between the sun and another star, you would wait a long time. Even over its entire life, the sun has probably 1,000,000,001 chance of colliding with another star.
But there are places within galaxies where the odds of a collision are much greater. Regions where hundreds of thousands or even millions of stars are crowded together by gravity into a globular cluster. Compared to the spiral arms of the Milky Way, a globular cluster is like a demolition derby. The odds of two stars colliding in the spiral arms of our galaxy are only about 1 in a billion. But within a globular cluster, stars are packed 1,000,000 times more densely than elsewhere in the Milky Way.
In the Milky Way, everybody is pretty much going in the same direction. But in the globular cluster, there's no organized motion. They're basically all orbiting around the center on orbits which are aligned in all sorts of different directions. So some are going one way, some are going the opposite way.
In these crowded, chaotic conditions, stars collide on average once every 10,000 years. Every star in a cluster was born at roughly the same time. So when astronomers look at an old cluster, they don't expect to see any young stars. But strangely, a globular cluster usually conceals some mysterious strangers. Large blue stars, far younger than the small dim stars surrounding them. These seemingly impossible stars are known as blue stragglers.
The mystery of blue stragglers is that they're, in some sense, younger than they have any right to be. All of the stars of that mass and that luminosity would have died off billions of years ago in these clusters. So the puzzle is, where did these things come from? How did they get into these star clusters?
Astrophysicist Joshua Barnes thinks he knows the answer. He believes blue stragglers are the result of collisions between older, dimmer main sequence stars.
A collision of two main sequence stars, two sun-like stars, is actually relatively gentle.
The mutual gravity of the stars locks them in a spiral.
They've lost energy of motion, and they will come back and have multiple subsequent passages. They heat up and swell up and kind of spiral around each other, making several passes each closer than the last one, until they finally come together and stars merge.
In the end, rather than triggering a catastrophe, the two stars merge to form one more massive star.
What you're basically doing is taking two small old stars, piling them together to make one star now, which is twice as massive, and therefore being more massive, it's brighter and bluer than the rest of the stars in the cluster. So it seems to be straggling behind the rest of the stars.
While the mystery of the blue stragglers seems to have been solved, the heavens are bursting with unusual objects that dare science to explain them. Black holes, neutron stars, and white dwarfs all represent the end of remarkable stellar lives. But there are other strange celestial objects that never got a chance to shine. Not quite planets, not quite stars, these are the brown dwarfs.
Brown dwarf is basically a failed star.
University of Hawaii astronomer Michael Liu searches for these elusive objects.
Stars produce a lot of light. They're very easy to see a long ways away, but brown dwarfs are very low temperature, and so they emit very, very little light. Because they're so dim, it means we can only see them if they're very close to us.
A brown dwarf has the same ingredients as a star, but it simply doesn't have enough mass to sustain nuclear fusion.
If something is born with less than 8% the mass of the sun, then it can't produce its own energy. It's essentially a failed star.
Without fusion, these failed stars start to act more like planets.
If you were flying in a spaceship across the surface of a star, you wouldn't really see anything that looked like clouds or mountains or anything like that. When you go to a brown dwarf, things begin to change.
We think their atmospheres in some ways might be similar to things like very massive versions of the planet Jupiter. If you're familiar with pictures of Jupiter, you see Jupiter has all sorts of banding structure and clouds on its surface. Although we've never taken a picture of the surface of a brown dwarf, we think brown dwarfs may also have similar cloud structure.
Now, these aren't normal kinds of clouds like we know about on the Earth. You have iron vapor making these clouds, and then the clouds may get thick enough that you get iron droplets raining out of the clouds. Obviously, a person wouldn't want to be there because these are molten iron.
To date, astronomers have located only a couple hundred brown dwarfs, and they still have many questions about these elusive objects. For one, they know some brown dwarfs have disks of dust and gas around them. Might those disks form into planets? That's just one of many mysteries yet to be solved as we continue to probe the stars. But already, science has revealed the universe to be a magical realm of dwarfs and giants, stragglers and supernovas. And hidden within the explosive life story of stars, they have found the very history of the cosmos and a key to understanding our own origins.